Hello friends, the next problem to attend now is we are given with a list of numbers and we would like to find for every number the next greater element in the list. That means we select any number and from that number we continue moving forward till we get the number bigger than that. Say we talk about 8, then we start moving from 8 to the right. 2, no, it is not bigger than 8. 3, no, it is not bigger than 8. 6, not bigger than 8. 10, yes. So if I start from 8, 10 is the greater element which is coming next. So this is the logic. So that means if you look at it, 1, then it is followed by 4. 4, it is greater than 1. So 1 should get next element as a 4. Then if you look at 4, the next number is 3. So 3 is not greater than 4. So we continue 8. Yes. So 4's next greater element is 8. Now coming to 3. Yeah, next element itself is great. So 8. Then coming to 8. Yeah, just now we have seen. Till 10, no chance. From 2, immediate next element 3 is greater. For 3, next element 6 is greater. For 6, next element 10 is greater. For 10, next element 12 is greater. And for 12, 6 is not the greater element, so it continues, so it goes to 20. So for 12, 20 is the next greater element. And for 6, of course, 20 is the next element. And 20 is being the end of the list. So the next element of 20 is represented by null or numerically -1. So this is what is expected from this is what the expected solution for this given problem. Problem is to generate the next greater element for each element in the given list. So the example, we have a list here and we are expected to find these answers. Yeah, what did we do? So we started from here and then went on looking till went on neglecting smaller values till you get a bigger value. So yes, you can do that. So from 8, you can leave 2, you can leave 6, you can leave 3, you can leave 6 and then go to 10. So if you're talking about some pointer like thing, then from 1 you go to 2, 4, then you get answer. From 4, you get to 3, no, then you go to 8, yes. Now once your pointer has shifted to 8, then you can't work with 3. So you need to work for answer for 3 also. So that's just a single pointer like thing cannot be useful. So what is useful? Let's just check out. And what we need is something to remember. And what we need to remember is the immediate past, not the long past. We need to remember very immediate past. So the only thing available with us to remember immediate past is what we call a stack. So what is the rule? So we get the data, dump onto the stack, and then if the next data, if you get a bigger than that, yes, the problem is solved. So so what is that? Let me take an example and start. So first element 1, push onto the stack. The next element is 4. So what is on the top of the stack? On top of the stack it is 1, and what you have now is 4. So just check, is 4 greater than what is there on top of the stack? Of course, yes. So that means 4 comes after 1 and 1 is, this 4 is bigger than 1. So the answer for 1 should be 4. So you write answer 4 in this. So we have another table which talks about the current values and the next biggest value. Okay. So this arrow logic, I am just trying to put it in the form of a table. Previous, next. Okay. Done. So once this work is done, so answer for 1 is available. So is necessary to remember 1? Definitely no. So forget 1. Then remember that answer for 4 is still to be found out. What comes next? Is 3. Is 3 greater than 4? Definitely no. Then what comes next? Is 8. Now what is top of the stack? 3. What we have now is 8. So is 8 greater than top of the stack? Of course, yes. So for 3, write the answer 8. So 3 is over. Now what is there on the top of the stack? 4. Is 8 greater than 4? Of course. So 8 comes here. Then this also is gone. So now after this, stack become empty. Push this new value into the stack. Next, who comes? 2 will come. Is 2 greater than 8? No. Then push. Then 3. Is 3 greater than top of the stack? Top of the stack now is 2. Therefore, 3 is greater than top of the stack. Of course. Therefore, the next value for 2 is 3. So 2 is popped. So should we pop the next element also? Yes, we can pop only if the new element is bigger than this, but the new element is smaller than this. Therefore, 8 will not get disturbed, and this 3 gets this position. Done. Okay, who is next? Next is 6. Is 6 greater than top of the stack? Of course, yes. Therefore, in place of 3, write a 6. So 3 goes out. Then next top of the stack is 8. Is 6 greater than 8? No. Therefore, just push 6 onto the stack and then continue. Then comes 10. Is 10 greater than top of the stack? Of course, yes. Therefore, pop 6 and against 6, write the current value 10. Next, we have one more element. So, is this to be popped? Yes, it can be popped if this value is less than the current value. Current value is 10 and this value is 8. Of course, this also can be popped. Therefore, we get a 10 here. And then the whole stack has become empty. And this new value 10 gets pushed onto the stack. So who is next after 10? It is 12. Is 12 greater than 10? 10 is on the top of the stack. So is 10 greater than, is 12 greater than 10? Of course, yes. Therefore, 10's output is 12 and 12 gets onto the stack. Then who is there next? Next is 6. Is 6 greater than 12? No. Then push. So the logic is if the current value is greater than top, if current value is greater than top, then pop, else push. What do you push? The current value. And what do you do for the popped element? You put it in the position of next. Done. Okay. So we have 6 and top of the stack was 12, so 6 is not greater than, therefore 6 is pushed onto the stack. Then next comes is 20, and compare 20 with the top of the stack. Of course 20 is greater than 6, so against 6 write 20, and then you have one more element on the stack. Is 20 greater than top of the stack, which is 12? Of course yes. Then for this also, and against 12 write 20, then push 20 onto the stack. What is next? Next is end of the thing, so which means just write that end of the thing and then pop. So if current is equal to -1, then what next equal to -1, and then pop it from that. So stack becomes empty. We started with an empty stack and ended with an empty stack, and we have this result here. So it says 1 4 1 4. So just compare 1 4, yes 1 4, 4 8, yes 4 8, 3 8, 3 8, 8 10, 8 10, 2 3, 2 3, 3 6, 3 6, 6 10, 6 10, 10 12, 10 12, 12 20, 12 20, 6 20, 6 20, 20 minus 1, 20 minus 1. Yes, we have done it. This was done using our intelligence, and this is done using code. So that's an algorithm for finding the next greater element in the given list for every element in the list. So that's it for now. This is an example how stack can be useful in solving this type of problems. So many more such issues to come in future. Keep watching. Thank you.